Howdy! We will continue today with our problems on work and work energy theorem. This is recitation style videos and this is problem 3. For problem 3, we have a block on inclined plane. Coefficient of friction between the block in the plane is given. It is mu. A man is trying to keep the box from moving down. He is pushing on the box. So despite his effort, the block first moves down to point B, distance B, and then this man pushes the box back. So the box starts from rest and slides down the plane to the point distance B from the top, and then gets pushed back to the top, where it is again at rest. We will answer several questions. First question will be, what is the work done by the force of gravity for the round trip on the way down and then up? Work done by gravity. Well, first of all, let's figure out our coordinate system. I wrote two formulas here. First of all, formula how to find work done by force, and then I wrote work energy theorem because we will need it to answer next questions. So far, we need just the first formula because we are looking for work done by gravity. Gravity is vertically down. That's a challenge. I think it looks like vertically down. This is gravity. Now I want to choose coordinate system. So which coordinate system do you want to choose? I will choose x along the inclined plane and y perpendicular. It's important to understand that work done by force does not depend on your choice of coordinate system. So whatever you choose, you have to get the same work done by this or that force. So this will be my coordinate system because I have here fx, dx, fy, dy. Now I need to figure out fx and fy. Well, this is force of gravity. We did it many times. But first of all, let me let me find work done by gravity on the way down. Work done by gravity on the way down. First of all, I will draw this gravity, force of gravity one more time. This is theta. I project it. This is line perpendicular to the inclined plane. This is 90 degrees. This is my x projection. This is x, this is y. So we understand that this angle is theta, this angle is theta, and x component of gravity, f sub x, will be mg sine of opposite angle. And since my x is down, x component of gravity will be positive. So I'm ready to write this integral. Where do I start? I start at x0. I go to x, which is equal to b. Projection of gravity f sub x is positive with my choice of coordinate system. It is mg sine theta dx. I'll need more space, so I'll probably draw this line. We will use this space later. And I take this integral. It is mg sine theta x. I plug in the upper limit. It gives me b, and low limit will give me 0. So work done by gravity on the way down is mg sine theta b. Now work done by gravity on the way up. By the way, why did I ignore the second part of integral? I do have fy for gravity. Fy for gravity is non-zero. It is mg cosine theta with minus. It's negative component of gravity with my choice of coordinate system. So there is y component of gravity. However, the limits in y with my choice of coordinate system will be from 0 to 0. So y is 0 here, y is 0 here. From 0 to 0, the second integral will be 0. That's why I wrote here only fx dx. Great. Now on the way up, where do we start now? Now we start at b and we go up to 0. I use the same coordinate system. mg, projection of mg is positive mg sine theta dx. Second integral fy dy will give me 0 again because y1 is 0, y2 is 0. So I'm done. And I take this integral, it will be mg sine theta x. And I plug in the limit 0 minus b, upper limit minus lower limit, which will give me minus mg sine theta b. Now, what is work done by gravity for the round trip from 0 to b and then back to 0? It is 0. Now, can I use different coordinate system to find work done by gravity? Of course. So for the second, we will get obviously same result, but I want you to be flexible, and I will just show you that if I use a different coordinate system, I will get the same result. Now I want my y to be up and x, whatever, let it be this one. So y is up, I need to choose the origin, let this point be point 0, and this point then is what? I will call it h. So this distance we will call h. 0, h in y. And we understand that h, in terms of what is given from this right triangle, this is theta, this is theta. So what is h? It is hypotenuse b times sine theta. H is b sine theta. Okay, so I will, for this coordinate system, I will work with blue marker. Work done by gravity. Work done by gravity in my blue coordinate system on the way down. On the way down. Okay, so here's the integral. F sub x is 0. With my new coordinate system, I have just fy, which is minus mg. So I have integral minus mg dy. What are the limits? I go from this point to this point. This point, this point in my y is h. This point is 0. So the limits are from h to 0. And we take this integral, we will get minus mg y. And the limits 0 minus h, I get mg h. Is it same or different than this? Since h is b sine theta, it is the same as what we have on the left. So my work done by gravity on the way down is mg, and h is b sine theta. Now work done by gravity on the way up. On the way up. Now I go from this point to this point. I start at 0. I end up at h. Projection of gravity is fy negative mg dy. I take this integral. It is minus mg h. And if I plug in h, I will get minus mg. H is b sine theta. Again, I ignore the first integral because f sub x with my coordinate system for gravity, f sub x is 0. Now, no matter which coordinate system you choose, you get the same work. Work done by gravity for the round trip 0, b 0, of course, is 0. Can we understand it immediately without even taking this integral? So I wrote these integrals because with time, we will work with forces that will depend on x and y, and we will need this integral. But for the force of gravity, that is constant force, can we write the answer immediately? Let's think about it. So force on the way down, let's think about down. On the way down, gravity is down, displacement is down, so work, which is dot product F dot displacement, work has to be positive because force and displacement are in the same direction. And what is, so it is positive. What is magnitude? Magnitude of force is mg. Displacement is h. If I don't even introduce coordinate system, displacement h, what I'm looking for? I'm looking for the component of the displacement that is parallel to force of gravity. This is force of gravity. Wait. This is force of gravity. This is displacement. Great. mgh, done. And work is positive because force is in the same direction as displacement. Now on the way up, what is work done by gravity? Work done by gravity on the way up without any integrals. So on the way up, the displacement is up and gravity is down. So they are anti-parallel. Dot product cosine pi is -1. The anti-parallel work is negative. What is magnitude? Okay, gravity is mg. The component of the displacement parallel to the force is h, and it is again minus mgh, same as we found that we took this integral. Now you express h in terms of what is given. In this case, it is b sine theta, and you get same result. So just double check, can we do it without taking integrals because force is constant? Yes, we can do it. So we answered the first question in this problem. What is work done by the force of gravity for round trip from 0 to b and back to 0? Next question. For the next question, we will work with force of friction.